Relationship between velocity and linear speed and angular speed. Remember how length is related to an angle by s equals r times theta? If we divide both sides by time to get so that one side we have length over time and on the other side we have angle over time. Length over time is speed, angle over time is omega. V equals r times omega. Remember how speed is v equals 2 pi r over period and omega is 2 pi over period? We can regroup the speed equation into v equals 2 pi over the period times the radius. So all we're doing is just taking this r out of the numerator and multiplying it. The 2 pi over t is the same as omega, so we get v equals omega times r. So as long as we can measure the angle in radians, we have a nice equation, v equals omega times r, that relates linear speed, v, to the number of meters of length traveled around the circle every second, to angular speed, omega, the number of radians of angle traveled around the circle every second. So, quick recap on these equations. So we have s equals theta times r. So we have this distance, the arc length, equal to the angular distance that has been traveled. If we take our linear equivalent, velocity, and we have our angular equivalent, angular velocity, and multiply it times r. All we're doing is just taking the linear and dividing out the radius. So rearranged, we have angular displacement, or angles that we've gone through, equals our linear distance divided by r. Angular velocity equals our linear velocity divided by r. This equation is given to you on the equation sheet in the geometry section, so you're probably not going to find it quickly. It's useful to just remember this equation. If you can remember this equation, you can also remember this equation, because all you're doing is substituting. This was distance, angular displacement, or displacement, angular displacement, velocity, angular velocity. Or you can just remember that to get your angular displacement, you take the linear version and just divide the radius. Now the two animations show 4 objects making different circular motions. On the left, all 4 objects have the same linear speed v because they go the same distance, arc length every second. Note the streaks are the same length. On the right, all 4 objects have the same angular speed, omega, because they all make the same angle every second. Looking at the left animation, I'm just in the way, where all objects have the same linear speed v, which object has the greatest angular speed, omega? It's the red object, because it makes more angles every second. So more angles every second gives it a greater angular speed. For the red object, v equals big omega times a smaller radius. So the small radius means a large angular velocity. For the green object, we have a huge radius, so that must mean we have a smaller omega, because remember, these have the same linear speed on the left. On the right animation, all objects have the same angular speed. Which object has the greatest linear speed? It's a green object because it travels a greater distance every second. Right? So every second that goes by, it's covering more ground. For the red object, little v equals same omega times r. So small r is a small v. For the green object, big V because of the big R.